Today you are going to learn about compound microscope. First we are going to learn how to draw the ray diagram in the case of compound microscope. Later we are going to derive the expression for the magnification of the compound microscope. Before going to learn about compound microscope, we should know why we have to construct a compound microscope. Already we have learnt about simple microscope. In the case of simple microscope, only one lens was used, convex lens was used, and the magnification in the case of simple microscope is very less. Therefore, we have to go for the next type of microscope called compound microscope. In the case of compound microscope, two lenses are used. One is called objective. The small focal length convex lens is called objective. Therefore, it can be named as O. And another lens that is taken here, that is called eyepiece, because you are going to keep your eye to look at the magnified object. Since this lens is very closer to the object, this is called objective, this one is called eyepiece. Now I am going to draw the ray diagram. Drawing the ray diagram is very important. At the time of examination, without any flaw, without any mistake, you have to draw the ray diagram. You have to take one small tiny object that is to be magnified. The object to be magnified, that should be kept between FO and 2FO. This objective, it has got principal focus on either side. They are marked as FO, and the twice of the principal focus is named as 2FO. The object to be magnified, that should be drawn here. So this is a small tiny object that is named as AB. That is named as AB. This object to be magnified. Now we have to draw the ray diagram. One ray is passing through that is traveling in this direction parallel to the principal axis. After getting refracted, that is traveling in this direction. Are you clear? That is traveling in this direction. It is passing through FO. Are you clear? Another ray is traveling in this direction. Another ray to be taken from the head of the object, and look at here, the ray to be extended right from the head of the object, that is passing through the center of the geometric center of the lens. Now this ray to be extended. Look at here, both ray to be extended. Both the rays are extended here. Are you clear? So this is the ray that is traveling in this direction. Are you clear? Both of them to be extended. Can you understand? So both are traveling here in this direction. So this is the location of FO. Now these two rays, they are traveling in this direction and both are meeting here. What is FE? That is the principal focus of the eyepiece. That is the principal focus of the eyepiece. And its focal length is also more compared to the focal length of the objective. Focal length of the eyepiece is greater. Now this focal point, now we are going to get the image which is produced by the, which one? This objective that can be caught here. Now I am going to draw the image which is produced by the, which one? The objective. Are you clear? That one produces the image. This image can be named as, here the object is named as AB, therefore the image must be named as B dash, A dash. So this is the image which is produced by the objective. Are you clear? So you will be getting the inverted image. Are you clear? Inverted image means here the object is in the erect nature, just it is drawn above to the principal axis, here drawn just below to this. Therefore the nature of the image will be, how the image will be, I will write it here. The nature of the image is that can be caught on the screen. That can be caught on the screen. Therefore it can be called as real, and it is magnified, and it is inverted. Such kind of image is caught here. You have to understand this. So that is the nature of this image. Are you clear? The main thing is, while getting this image, that image it has to fall between the center of this eyepiece and principal focus of the eyepiece. Within this FE and E, the image must be cut. That is very, very important. Can you understand the point? So, while the image is cut here, that should be within FE. That is very important. Can you understand? Now, I am going to draw the distances. Are you clear? Now, first I am going to draw the distances. This is the object now. So, right from here, that object, it is at a distance of u, that is called object distance. And then in between O and FO, another small distance is there. That is called focal length. That focal length can be written as, what is this? FO, small FO. And this is also FO. Therefore, this distance also will be equal to what? FO. Any doubt on this? And then distance between FE and E. Distance between FE and E. That is also called as, what is this? Focal length of, which one? Focal length of eyepiece. So this is called focal length of eyepiece. That is called FE. Can you understand? Look at how many distances are there. U, object distance. FO, focal length of the objective. Here also focal length of objective is there. This is the focal length of eyepiece. Now same FO that can be drawn in the upward direction also. Are you clear? So this is called, what is this? FO. Are you clear? Here FO is there, here FE is there. In between one distance is there, no? That is called as L. Are you clear? That is called as, what is this? L. This is called as L. L that lies in between this point and this point. That L, you should know what is L. That L is measured between focal point of the eyepiece and focal point of the objective. This L is called as tube length. This L is called as, what is this? Tube length. Are you clear? Okay. After getting the image, now we are going to continue the ray diagram. So this is the image which is created by the objective. Now this image that is going to act as the object for this eyepiece. So from the head of the object, one ray to be drawn. After getting refracted, what will happen? The ray will pass through the principal focus of the eyepiece. Are you clear? And another ray that is passing through from the same head of the image, another ray that is passing through the center of the eyepiece. Look at here, both the two rays are diverging, and your eye position should be here. Your eye position should be here to view the object. Now you are able to observe the magnified image. You are able to observe the magnified image. Now this line, these two rays to be extended here. Look at how that ray diagram is very beautifully that is obtained here. So extend the line and you will be getting the magnified image of this small tiny object. Okay. That should be drawn by dotted line. That is very important. Why it is drawn in dotted line? Because you are going to get the virtual image. This is the image and its nature is real, magnified and inverted. The final image will be virtual image. To represent the virtual image, you have to draw the dotted line. Okay. And the nature of the final image will be virtual in nature. I will write it here. This is the final image. Final image, and it can be named as B double dash, A double dash. This is AB, no? Clear. This one was magnified by the first lens, objective. That one was named as B dash, A dash. The final image can be written as B double dash, A double dash. Can you understand the point? Here the nature of the final image will be, it cannot be caught on the screen. Therefore, it can be called as virtual. Why it is called virtual? It cannot be caught. and it is magnified. Are you clear? It is magnified by several times. It is magnified one and inverted. Are you clear? The nature of the image will be inverted in nature. Such kind of image can be seen by your eye. So, though the object is too small, the magnified image will be very much greater than the size of the object. Several times it can be magnified. That is the advantage of using compound microscope. Understood? Next, we are going to derive the expression for magnification of the compound microscope. Are you clear? Since two lenses are used and you are getting the more magnification, that's why this is called as compound microscope. Both the two lenses both have to be fitted in the same tube. Are you clear? In the coaxial tube. And the distance between the two lenses can be adjusted. Are you clear? With the help of rack and pinion arrangement, we can adjust the distances. Okay. Now we are going to derive the expression for magnification of compound microscope. Here, look at the objective. There the object is kept and its height is h, and the image is caught here, its height is h dash. Now we have to find out how many times the object is magnified here. First we have to calculate the magnification of objective. What is the formula? Height of the image divided by height of the object. For this we have to find out the formula. Here in this triangle part, in the triangular part, the same part is drawn here. There you are getting one small angle called beta. The same angle beta is existing here. This is called tube length. From this diagram you compare, you will get it. L is the tube length. And then this is called height of the image. This one is height of the object, and this one is the focal length of objective lens. So from these two triangles we are able to get the formula for tan beta. Okay. So tan beta can be written as tan beta is equal to, here from this triangle in this part you are able to get opposite by adjacent, h dash divided by L can be written. From the other part of the triangle the same tan beta can be obtained, opposite by adjacent, h divided by FO can be obtained. From this part you are able to get the h dash by HO. Just you cross multiply this. After cross multiplying you will get the value h dash by h dash divided by h is equal to, what will happen? This L will go up, L divided by FO you will get. H dash by h is nothing but MO. What is MO? MO is called magnification which is produced by the objective lens. Already I have told this image, that one will act as the object for eyepiece. Are you clear? This one will act as a simple microscope. In the case of simple microscope, in the case of near point focusing, what is the magnification formula? ME. What is ME? ME means magnification produced by eyepiece. This one part alone acts like a simple microscope, and we are able to see the object at a distance of 25 centimeter. Are you clear? That's why this is called as near point focusing. So ME is equal to 1 plus D by FE can be written. So this is a magnification formula which is produced by eyepiece. Already you have learned the same concept in simple microscope. Now this one acts as a object for this eyepiece, and this one to be treated as a simple microscope. Therefrom we have got this formula. Are you clear? Now we are going to get the total magnification which is produced by the compound microscope. So how to get this? M is nothing but magnification of the compound microscope is equal to, how to write this? MO into ME. Are you clear? The product of MO and ME, that gives you the total magnification of the, which one? The compound microscope. Now MO is already found out, L by FO can be written. Are you clear? That should be multiplied by which one? ME 1 plus D by FE. So this is the formula to be used. Are you clear? When this formula can be used? In the case of near point focusing. Are you clear? In the case of near point focusing, when the image is caught very nearer to the eye, are you clear? By that time, this formula can be used. If the image is caught very far, if the image is clear caught at very far from the eye, by that time we have to go for normal focusing. By that time what will happen? This factor cannot be written, d by fe alone can be written. Therefore, m is equal to L by Fo into, in the case of normal focusing, what is the magnification? In the case of simple microscope, d by Fe. Therefore, d by Fe must be written. Are you clear? So, this is a formula to be used to calculate the magnification in the case of normal focusing. So, there are two formula. Are you clear? There are two formula to calculate the magnification in the case of compound microscope. One is in the case of near point focusing and another one is in the case of normal focusing. Two formulae are there. Are you clear? You have to read the problem thoroughly. If any problems are asked based on the magnification of compound microscope, you have to check it up whether it is given on the basis of near point focusing or normal focusing. On the basis of that, you have to use the formula. Are you clear? Very interesting one. Prepare the question thoroughly, may be asked in the exam. Okay.